Match list 1 with list 2. Here list 1 consists different types of pairs like self-closed pair, force-closed pair, higher kinematic pair, lower kinematic pair. And here list 2 consists the nature of the pair, line contact or surface contact, or two elements of pair not connected, two elements of pair connected. Here if you consider self-closed pair, in this pair two elements of pair are not connected, and if you consider force closed pair, two elements of pair are connected, so that here P is matching with 3 and Q matches with 4. And here higher kinematic pair is nothing but line contact, it has line contact, and lower kinematic pair having surface contact. So that R1 and S2 in the option, the right option is C. Is my z is equal to 3x1 plus 9x2 subjected to the following constraints: x1 plus 4x2 less than or equal to 8, x1 plus 2x2 less than or equal to 4, and x1 x2 greater than or equal to 0. The solution for the LPP is, actually it is the case of degeneracy, and here the right answer is degenerate. A cylinder liner manufacturing company has a contract to supply 5000 liners to an automobile factory per day. The company has capacity to manufacture 8,000 liners per day, and holding cost of 1000 liners is 25 paise per day. Setup cost is 20 rupees. What would be the total inventory cost per day on optimum basis? Here on optimum basis, the total inventory is given by inventory cost is given by 2R C1 C3 1 minus R by K, where R is the capacity, the supply or demand, that is 5000 liners per day, and the company has capacity to manufacture 8000 liners. So here K represents the capacity, the production rate, that is 8000 liners per day. And here the holding cost is of 1000 liners, the holding cost of 1000 liners is 25 paisa per day. So here C1 is equal 0.25 per 1000 liners per day, that is 0.25 into 10 power of minus 3 per day. So it is in rupees, and C3 is equal setup cost, that is equal 20 rupees per setup. So now substitute all these values in the given equation, which gives a value of 4.33 rupees per day. This is called inventory cost per day. So in the option, the right option is C. Delphi method of forecasting is A. Here the options are opinion method, time series method, casual effect method, and judgmental method. And here the right option is opinion method. Objectives embodies in the master schedule can be met by using which of the following techniques. Here the options are MRP and MPS, MRP and LDR, MRP and MRP2, MRP and CRP. The right option is MRP and CRP. Two parallel plates having an area of 0.5 meter square are placed 0.5 meter apart from each other in a room of which walls at 300 Kelvin. One plate is maintained at 1273 Kelvin and another at 773 Kelvin. Emissivity of plates are 0.2 and 0.5 respectively. The plates exchange heat with each other as well as with the room. The radiosity of the plates are 33.469 kilowatt per meter square and 15.054 kilowatt per meter square. Considering that only plate surfaces facing each other, so it is a common data question. It consists two questions. Here the first question is find the radiosity of room walls, and here the second question is total heat lost in kilowatts by plate 1 and plate 2 respectively. Here radiosity of room wall is given by sigma, the room wall temperature power of 4. Here where sigma is 5.67 into 10 power of minus 8, and here room wall temperature is 300 Kelvin power of 4, which gives a value of 0.4592 kilowatt per meter square. So in the options, here the right option is B. B the right answer for this first question. And coming to the second question, we will have to find out the total heat lost in kilowatts by plate 1 and plate 2 respectively. Here the heat lost by the plates is given by, first consider the heat lost by the plate 1, so which is equal to EB1 minus I1 by 1 minus epsilon 1 by A1 epsilon 2. So here EB1 comes from the sigma T1 power of 4 minus I1 is the radiosity of the plate 1, that is 33.469 is given value, and here epsilon 1 is 0.2 and A1 is 0.5 and again epsilon 1 is 0.2. Here it is 0.1, sorry, epsilon 1. So here sigma is a known value and T1 is a known value. Here T1 is given as 1273 Kelvin. So from this we can get the heat loss by the first plate is 14.42 kilowatts. So in the same way, heat loss by the second plate is given by EB2 minus I2 by 1 minus epsilon 2 by A2 epsilon 2. So which gives a value of 2.59 kilowatts. So in the options, the right option is 14.42 and 2.59. So the right answer is A. A is the right answer.